We have a quadratic equation set to 0, and we want to solve for x. How do we do that? Well, one way is to use the quadratic formula, where x equals negative b plus minus the square root of b squared minus 4ac all over 2a. And for many of us, we've memorized this formula, and we take the coefficients a, b, and c, we plug it in, and voila, we get the values for x. But we're not really understanding what's going on here. Let's look at it from a different angle, the geometric angle. So we take our original equation and we divide a across all the terms. And now we're left with x squared plus b over ax plus c over a equals, and 0 over a is 0. If we represent the first term as the area of a square where the lengths are side x, we can do the same for the second term, where one side is length b over a and the other side x, and the area is b over ax. If we split that rectangle into two, we could see that the area of the smaller rectangles is b over 2ax. And if we reorient it, we could see that we have nearly a perfect square, except for a small piece on the bottom right. What would that area be? Well, that's b over 2a squared. And if we simplified it, it would be b squared over 4a squared. Now, if we zoom out, we could see that we could represent our original equation as the area of the shaded region in blue. In other words, it would be the area of the complete square minus the smaller square that we added. What would that look like? Well, the area of the big square is x plus b over 2a squared minus the area that we added, the b squared over 4a squared, plus our original term c over a. I think you see where this is going. If we simplified this, we would see that we would arrive at the quadratic formula. How cool is that? Not only we know how to use the formula, but we have a much deeper understanding about where it came from and how we could derive it geometrically.